Okay, so with number one, the question is what is the x-coordinate of the point of inflection on the graph of y equals 1/3 x cubed plus 5x squared plus 24? First thing we need to know is where a point of inflection occurs. All right, so that means we're going to need some derivatives. The first derivative is x squared plus 10x, and we want to know where that changes sign, which is that one's maximum. And we want to take the second derivative, set that equal to 0. We have found that the x-coordinate is going to be -5 for your point of inflection. All right. For number 2, the graph of a piecewise linear function f for -1 less than or equal to x is less than or equal to 4 is shown above. What is the value of the integral from -1 to 4 of f of x dx? Remember, the integral of a function expresses the area under the curve. This is a non-calculator problem. You have to do some algebra. You have to do some basic geometry. You can find the area of that trapezoid, which is area 1, or you can split it up into 2 triangles and a rectangle. I don't care, whatever floats your boat. And then we're taking away the area under the x-axis since we are taking away from the positive area. When we make sure to take the area of that trapezoid or triangle and square, we find that we will end up with 4 minus 1.5. That is 2.5. Notice that there are distractors that are going to be just the value of that 4, the value above the x-axis, the value of 1 and 2 added, so d. All right, for 3. We have the integral from 1 to 2 of 1 over x squared dx. We can rewrite that where we end up just dealing with the power rule. And we have the integral from 1 to 2 of x to the -2 dx. So we have -x to the -1. I always double check by taking the derivative again in my head if I can, if it's something nice. Especially things that have weird signs like this. And we're evaluating that from 1 to 2. All right, when we plug that in, I have -1/2 minus -1, which ends up being -1/2 plus 1 is +1/2. Okay, for 4, if f is continuous for a less than x less than b inclusive, and is differentiable for a less than x less than b exclusive, which the following could be false. So I want to make sure that I see that it is false, do something to indicate it, especially if it is something that you're not expecting. Okay, if it's false, I'm going to start looking at the things that only have one part changed. So I have f is a minimum value and f is a maximum value. If we have a continuous function on a closed interval, that means there has to be some maximum and some minimum. So both of those are true. The next thing we want to look at is that f prime of c equals f of b minus f of a over b minus a. Hey, what is that? That's the MVT. What are the requirements of the MVT? That we have a continuous and differentiable function as defined. So that can't be false. That is a part of the statement. The last part we want to look at is e, integral from a to b f of x exists. So we have a continuous differentiable function. That means that we will be able to find a value of the integral. It's the same idea with the MVT. All right, so we're left with b. B is a very specific application of the MVT, otherwise known as the Rolle's theorem, or Rolle's theorem, because Rolle is a person. This is only true when a is equal to b. If we aren't given that, everything else doesn't necessarily have to be true. Okay, for 5, we have the integral from 0 to x of sine of t dt. We're integrating with respect to t, and since we're integrating sine, that's going to give us cosine, but the derivative of cosine is negative sine. We throw a negative in there, and we're evaluating, from 0 to x. Here, We are plugging in those values. The value of cosine of 0 is 1. So I have negative cosine of x minus negative 1, which is negative cosine of x plus 1. Switch the places of those guys to have what the answer is given to you in the multiple choice. All right, for 6, we are given x squared plus xy equals 10, and the value that x equals 2, we need the derivative. So we're going to take the derivative of each individual term. As we take the derivative of each individual term, we need to make sure that we're taking the derivative of terms with respect to both variables, so that xy, we need to take the derivative with respect to x and derivative with respect to y. We can rearrange algebraically to solve for dy dx, and we are left with the expression 2x plus y over negative x. Now, since we know what the value of x is, we still need the value of y to compute your derivative value at x equals 2. Sometimes this isn't the case, which is why I usually wait to solve for y until I know I need it. So I've plugged in x equals 2 to all of the terms. That gives me that y equals 3. I can go back to my derivative, plug in that 3 and that 2. So I'm evaluating at the point 2, 3. I end up with negative 7 halves. All of these distractors are things that can occur because of an algebraic error, which is what they're going to plan on tripping you up on, especially since it's a non-calculator problem. Be careful with that. All right, so for 7, I think the easiest way to approach the integral where you have terms that seem hard to integrate is by splitting up the fraction if possible. That simplifies each term in your function that you're integrating, and it might allow you to split up your integral to make it a little bit simpler. All right, after doing that, I can integrate both these things. I now have a quadratic term and a natural log. Once I integrate, it's just a matter of evaluating correctly. I plug in e's and then I plug in 1's. Be careful with your signs. Make sure that you remember the major points on natural log as far as evaluating. Natural log of 1 is 0, natural log of e is 1. You can think about that as their inverses. And you end up with e as your final answer. Okay. So for 8, we are given some information about a function and then a product of those functions. So what this is really asking us to do is look at the product rule and see what is different in our answer than what is in the product rule. When we are given the fact that our derivative of h is f times g prime, that tells us the first part of the product rule, f prime g, is equal to 0. We know that g is greater than 0 for all of our terms, so f prime has to be equal to 0. Since f prime is 0, that tells me that f of x is a constant value. If f of x is a constant value and we know that f of 0 equals 1, f has to equal 1. For number 9, this problem comes up in some capacity, either in an FRQ or on the multiple choice. We're looking at the flow of oil in barrels per hour through a pipeline on July 9th. This is giving us a graph of a rate and by time. Now, rate times time gives me a total. If I want to look at the total, I'm actually just taking the area under the curve from 0 to 24, which is the same as the integral. Since I don't know what b is, I'm literally just looking at the values given to me and approximating. Since we have a symmetric bell in number 5 that is kind of cutting across the part of the rectangle to make it half, we can combine them together and see that they take up approximately 1 rectangle. And I've counted all 5 areas that I've marked are the same. I have 5 times approximately 600. And again, this is non-calculator. If you need help reviewing basic algebra and you want some tips, let me know. All right, for number 10, what is the instantaneous rate of change at x equals 2 on the function f? Instantaneous means at a specific value. Rate of change means a derivative. So we're looking for the derivative of f at 2. Since f of x is a function divided by another function, we're going to use the quotient rule for derivatives, which is low d high minus high d low, all over low squared. Once I have an approximation of that, instead of multiplying out and simplifying, since I'm just plugging in x's, I think that'll be a faster way for me to solve. So I'm plugging in 2 for everywhere there is an x instead of multiplying out. Once I am there, I want to triple check my signs, make sure everything is written correctly, and I find that my value is 2. There are so many ways to make errors on this algebraically, so slow down for a minute, make sure you check yourself. For 11, if f is a linear function and we have the second derivative that we're integrating, that means we need to know something about the first derivative. So if f is a linear function, I just write out a basic generalization of a linear function, which is cx plus d. The derivative of that is going to be a constant. The derivative of a constant, as we covered in a previous question, is equal to 0. The integral of 0 from a to b is still going to equal 0, so our value of the integral asked about is always going to be 0. All right, 12. If f of x is this piecewise function where it is equal to natural log of x for x less 0 less than x less than or equal to 2, and is equal to x squared times natural log of 2 for 2 less than x less than or equal to 4, and we're talking about a limit, we need to look at the left and right hand side, which as x approaches 2 from the left, we're looking at natural log, that's smaller than 2, and as x approaches 2 from the right, that is bigger than 2, so we're going to be using x squared times natural log of 2. I can think about those limits as we're approximately plugging into. We're not actually plugging it in, but we're checking. I have 4 natural log of 2 and natural log of 2. Those are not equal to each other, so the limit does not exist.